In this section about probability, we're going to talk about the union, intersection, and complement of events, and specifically the probabilities of the union of events or intersection of events or the complement of an event. So this is very much going to look just like basic set theory. So let's let E and F be events from a sample space S. So how that corresponds to set theory is that S would be like the universal set, and E and F are simply subsets. So we're just kind of reviewing here, but E and F being events means that E is a subset of S, and F is a subset of S. So now we're going to look at a new event. We have the events E and F, but we're going to look at a new event called the union. The event E union F is the event consisting of all of the outcomes that are in either E or F. So when we look for the probability of this eventually, we'll be looking for the probability of E union F. And that's in other words the probability that after your experiment that either event E or event F occurred. So now let's look at the intersection. The intersection is written like this. The intersection of those events is the event consisting of those outcomes that are in both, simultaneously, they are in both E and F. So in order for the event to occur, both of the events to occur, the event that occurred, the simple event that occurred would have to be contained in this set and in this set, both of them. And next is the complement of an event. So the event E complement can be written like this with an E prime, looks like an apostrophe, or just put the bar over it. Either one of those is fine for the complement of the event E. It's the event consisting of those elements in the sample space that are not in E. So for example, if the event E happens to be the even numbers in the set, well, the complement of that would be the elements in the sample space that are the odd numbers in the sample space. Okay, so let me rephrase that. In the sample space, if the event E is the even numbers, the event E complement would be all of the numbers that are not even numbers, or you could think of them as being the odd numbers. Okay, well, to finish up this video, let's look at one example here. Let's suppose that our sample space is this. You could think of it if you wanted to, if there exists such a thing as a 10-sided die instead of 6 sides. This could be the possible outcomes. 1, 2, 3, all the numbers all the way up to 10. Let's let E be the event that the number is odd. Well, remember that E is a subset of this, so we're only talking about numbers in this sample space. And E is the event that it's odd, so E would consist of the numbers 1, 3, 5, 7, and 9, the odd numbers in the sample space. And if F is the event that the number is prime, we have to list all of the prime numbers in the sample space. And remember, the prime numbers begin at 2, that's the first prime number. And it's the numbers that are divisible only by themselves and 1. So 2, 3, 5, and 7. 9 is an odd number, but it's not a prime number because 9 is 3 times 3. So that's the event E, that's the event F, if we listed them out in set notation. And once again, just as a reminder, E is a subset of the sample space, F is a subset of the sample space. And going back to union and intersection, let's say I rolled that 10-sided die if it existed, and the number 10 showed up on the die. The number 10 was the outcome of the experiment. That means that E did not occur. F did not occur. So I could say that E complement occurred and F complement occurred. Because if the number if no number in the set E showed up, that means that the number that showed up is in E complement. Okay, so let's make that clear. Let's go through some more examples. If I roll this 10-sided die and a 1 shows up, the event E occurred because 1 is in the event E. The event F did not occur, which means F complement occurred. So E occurred and F complement occurred if the number in the experiment was a 1. And let's do one more. How about we roll this 10-sided die and the number 7 shows up? That means that event E occurred and the event F occurred. So, in other words, E complement did not occur and F complement did not occur. All right, well, we've pretty much exhausted that, but let's go ahead and write down these events. E union F would be the event, and I have to list every element in either one of these sets. 2, 3, 5, 7, 2, 3. Okay, so I've got to list 1, 2, 3, 5, 7, and 9. Notice that the union has more elements than either one of these two because it's containing every single element that is in either this one or this one. And once again, you do not repeat elements. Even though the number 7 showed up in both of them, I only list it once because in a set, you don't repeat elements. So 1, 2, 3, 5, 7, 9. The intersection is going to be a smaller set because it's the elements that have to be in both of them. So I'm not going to include 1, not going to include 2. 3 is in both of them. 5 is in both of them, and 7 is in both of them. So if I roll this 10-sided die and either one of any of these 3 elements showed up, that means that both E occurred and F occurred because 3, 5, and 7 happen to be in both of these sets. And if any one of these numbers showed up, I could say that E union F occurred because for sure either E or F or both of them occurred if any one of these numbers shows up. All right, finally we need to do this one and this one. E complement is simply all of the elements in the sample space except for the elements in E. So E is 1, 3, 5, 7, 9. E complement is going to be 2, 4, 6, 8, and 10. And I think we've mentioned this before, but the beauty of E and E complement is if you union them together, you get the entire sample space, and E and E complement share no common elements. It is impossible that an element is in E and E complement, because E complement is all of the elements that are not in E. All right, so to finish up this video, F complement, and again, I could have put the bar over it if I wanted to. I'll do it for that one. You can write it either way. It's going to be all the elements in S except for the elements that are in F. So don't include these ones. So we'll get a 1, 4, 5, 6, 7, 8, 9, 10. I hope I got all those correct. So once again, it should be the case, if I did it correctly, that if I take F union F complement, I get the entire sample space. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I intersect them, the intersection between F and F complement is the empty set.